Hey everybody, welcome back. So we're going to continue on in 1.3 and 1.4 and talk a little bit more about these right triangles. But what I want to focus on now is when we define the 6 trig functions, how do we know if our fraction value is going to be positive or going to be negative? There's an easy way to decide that. So let's go back and talk about drawing these right triangles. So remember, we're drawing triangles in standard position, so I'm still going to put my vertex point at the origin. I'm going to still put my initial ray on the positive x-axis. If I draw my triangle in quadrant 1, here would be my terminal ray. I would drop my perpendicular down. Here would be my acute angle theta. This side would be my x, this side would be my y, and this side would be my r. Now let's think about this a minute. If we're in quadrant 1, what sign would x be? Would it be positive or negative? Very good. In quadrant 1, x is positive. In quadrant 1, is y going to be positive or negative? Good, because we're going up, y would be positive. And the radius is always positive. So in quadrant 1, if we draw our triangle, our right triangle in quadrant 1, we know always all 3 numbers, x, y, and r, would be positive. So no matter which one of these definitions we set up, a positive number or a positive number would always be a positive number. Therefore, it doesn't matter which of these 6 trig definitions we're finding the answer to. If all the numbers in quadrant 1 are positive, we are guaranteed all 6 of these fractions will be positive. And we're going to remember that by putting a big A in quadrant 1. The A represents all 6 trig functions would be positive answers. Now the question is, will that always happen? If we move the right triangle to quadrant 2, would all 6 functions be positive? Well, let's look at that. If we move our triangle to quadrant 2, what would our x value be? That's right, it's going to the left. The x value would be negative. What would the y value be? Well, it's still going up. It would be positive. What would our r value be? Well, r is always positive. So if we're in quadrant 2 and we're going to define the 6 trig functions, would all 6 of these fractions all have a positive? No, they wouldn't. Because if you're dealing with x, the x value would be negative. So do you all agree if I did x over r, if I found the cosine here, this would be a negative over a positive, which would be a negative. And if cosine's negative, then secant would be negative, because it's the reciprocal. Also, tangent, if we did y over x, y is positive, x is negative. Well, a positive over a negative is a negative. So if we draw the right triangle in quadrant 2, we know because the x value in quadrant 2 is always negative, these 4 trig functions, cosine, secant, tangent, and cotangent, are always going to be negative numbers. These fraction values are going to be negative, which means the only function that's positive is sine and its reciprocal. Because sine is y over r, y is positive, r is positive. Cosecant is r over y, positive and a positive. Well, the way we remember that is we put a big fat S up here. That S says in quadrant 2, sine is positive. And if sine is positive, its reciprocal is positive. So A means all 6 trig functions are positive answers. In quadrant 2, it means only sine and its buddy, cosecant, are positive answers. The other 4 fractions would be negative. That makes sense, right? Now let's draw the triangle in quadrant 3. Well, if we draw the triangle in quadrant 3, we're going to the left, so x is negative. But now we're going down, so y is also negative. The radius is always going to be positive. So the question is, if I ask you to define the 6 trig functions in quadrant 3, would all 6 of these fractions be positive? Well, if we did y over r, a negative over a positive, that would be negative. And if sine is negative, cosecant's negative. If we did x over r, a negative over a positive would still be a negative. And if cosine's negative, its reciprocal secant is negative. If we did tangent y over x, y is negative and x is negative. But a negative divided by a negative is a positive. So this trig function fraction would be positive, which means its reciprocal would be positive. So if the right triangle is drawn in quadrant 3, you are guaranteed to know tangent and cotangent, these fractions would be positive, but the other four would be negative. We're going to remember that by putting a t here. T means tangent is positive and its reciprocal is positive. S means sine is positive and its reciprocal is positive. A means all six are positive. Cool? All right, we got one more quadrant. Let's go to quadrant 4. If we draw our right triangle in quadrant 4, the x value will be positive, but the y value is going down. It would be negative. The r value would stay positive because r is always positive. So now if we look here, if x is positive, y is negative, and r is positive, which of these 6 trig functions would stay positive? Well, if we do sine y over r, that's a negative over a positive, that would be negative. So if sine is negative, cosecant's negative. If we do cosine x over r, x is positive, r is positive, so this would be positive. If cosine's positive, its reciprocal secant is positive. If we did tangent y over x, y is negative, x is positive. A negative divided by a positive would be a negative. So everybody look, in this quadrant 4, which trig function will always stay positive? Well, it'll be the one with the x. So that's x over r or r over x. So in this quadrant 4, cosine will always be a positive fraction and its buddy secant. So you're going to have to memorize this phrase. All students take calculus. I know it's silly, but that's usually what happens. If you take trig, you're going to go to calculus next. All students take calculus. That is a good way to remember by drawing the triangle in the quadrants which fractions will be positive. That's what this tells you. When I write ASTC, all 6 trig functions, fractions are going to be positive. Sine and its reciprocal are going to be positive. Tangent and its reciprocal are going to be positive. Cosine and its reciprocal are going to be positive. That's a helpful hint. So when you're writing the fractions out, then double check yourself. Should the answer be positive or negative based on its quadrant? So let's look at some examples they're going to ask you in MyLS Plus, your homework. First one says, according to this information given, tell me if the sign value is positive or negative. So we're in quadrant 3A, we're in quadrant 2. All right, here's your triangle in quadrant 2. We're doing the definition x over r. Well, which trig function is x over r? That's cosine. So we know that this is the definition of cosine theta. In quadrant 2, is cosine going to be positive or negative? We don't need to know actual numbers. All we got to do is look here at a little cheat sheet. In quadrant 2, what does S stand for? Sine is positive. Now, is sine and cosine reciprocals of each other? No. So if sine is positive, that means cosine is going to be what value, everybody? It's going to be negative. So according to this cheat sheet, sine is positive means all the other trig functions are going to be negative. Okay? Let's look at 3B. What quadrant are we in? Quadrant 3. Here's quadrant 3. What's the definition of y over x? Well, y over x is what function? Tangent. So I am asking you, in quadrant 3, would the tangent fraction have a value that's positive or negative? Well, in quadrant T, here's the T. T stands for tangent. That means tangent would be what sign? Positive. So these letters, A, S, T, C, are telling you whether the function is positive. If that says T, it means it's positive. Okay. Next question is asking you, according to the information given, tell me which quadrant I am in. So let's look here. The answer they want to know is what quadrant are we in? Let's look at 4A. 4A says sine theta is greater than 0. What does it mean if you're greater than 0? It means you're a positive number. So if sine is positive, which quadrants are we talking about? Well, A means everyone's positive. So that means the triangle could be in quadrant 1. Is that the only place sine can be positive in? Nope. The S means sine can be positive. So that's quadrant 2. But there's another piece of information. Now it says, where is cosecant greater than 0? Again, what does it mean when you're greater than 0? It means you're a positive number, right? Anything bigger than 0 is positive. Where is cosecant positive? Again, what does A mean? All functions are positive, so that's quadrant 1. Now, here's the boo-boo. You guys are going to see C here and think it's this C. What does this C stand for? Cosine. Okay, it doesn't stand for cosecant. Cosecant is one of your reciprocal functions. Who does cosine always relate to? Who does cosecant always relate to? I apologize. Cosecant always relates to sine. So if sine is positive, cosecant would be positive. So which quadrant besides 1 is cosecant positive in? Well, cosecant goes with sine. Sine is positive in quadrant 2, so that means cosecant is positive in quadrant 2. So the question here is, which quadrant is sine and cosecant both positive? They both are positive in quadrant 1. They both are positive in quadrant 2. You don't choose which one you like better. You write both. That's the answer. If I drew a right triangle in quadrant 1, or if I drew a right triangle in quadrant 2, both of these fraction values for sine and cosecant would be positive numbers. All right, let's try the next one. Tell me the quadrant we are in. Tangent theta is less than 0. Now, what does it mean to be less than 0? To be less than 0 would be moving to the left of the number line, which means you are negative. So I need to know if I drew a right triangle, in which quadrant would the right triangle be drawn so the tangent fraction value would be negative? A means what? Everyone's positive. S means what? Sine is positive. Well, if sine's positive, everybody else is what, y'all? Negative. So in quadrant 2, tangent can be negative. T means tangent is positive. C means cosine is positive. If cosine is positive, everybody else is negative. So tangent would be negative in quadrant 4. If you don't believe me, watch. The definition of tangent is y over x. In quadrant 2, y over negative x would be negative. In quadrant 4, negative y over x would be negative. So in quadrants 2 and 4, if we drew the right triangles, our fraction for tangent would be negative. Now, they want the cosecant theta is greater than 0. Again, greater than 0 means the number is positive. What quadrant or quadrants is cosecant positive in? A means everyone's positive, so that would be quadrant 1. S means sine is positive, but who is sine's reciprocal? Cosecant. So if this fraction for sine, y over r, is positive, then its reciprocal cosecant, r over y, is also positive. Now on this one, if you look, they don't have the same quadrants. See up here they had both 1 and 2 in common, so we wrote both. I'm asking you, where would we draw the triangle where tangent would be a negative number, cosecant would be a positive number? Well, the only quadrant they have in common is quadrant 2. I'll prove it to you. If I drew a triangle in quadrant 2 and I asked you to find the tangent, tangent would be y over x. Y over negative x would be negative. Fits. If I drew the triangle in quadrant 2 and I asked you cosecant, r over y would be positive. So that's what you're finding. You don't need any numbers. All you need to understand is this little code word to help you decide which answer is going to be positive or negative. All right, let's go to 5a and 5b. Now, I like these. 5a says, given this information, find the remaining trig function values. How many trig function values do we have, people? 6. Okay, how do we find these 6? Well, to find these 6 trig functions, we have to have a right triangle because we got to know x, y, and r. So if you look, let's look at the information they're giving us. They're giving us one of the 6 trig functions. And then they're telling us what here? Quadrant 2. So they're coming right out and telling you the triangle is going to be drawn in quadrant 2. They're not giving you an ordered pair to plot and figure it out. They're not giving you an equation of a diagonal line to graph and figure it out. They're coming out and saying, draw me the right triangle in quadrant 2. So let's do that. There's your initial ray. There's your terminal ray. I drop my perpendicular down to the x-axis. There it is. Now, the problem with this is I need some information because in order to do the 6 trig functions, I have to know what x, y, and r are. Well, if we use this piece of information, the only other piece we got left is here. So it's all about definitions. What does it mean when tangent theta is negative 15 over 8? Well, tangent stands for what, y'all? Y over x. So you're being told the y value is 15, and you're being told the x value is 8. The problem is there's a negative sign. So it's all about arithmetic. Does that negative sign belong to the negative 15? Does that negative sign belong to the negative 8? Or does it belong to both? All of you that said it belongs to both, shame, shame. What would be a negative 15 over a negative 8? A negative over a negative would be a positive. So this sign doesn't belong to both. It doesn't automatically belong to the numerator. Because remember, it could have been down here and then floated it up. You have to look at the picture. You know your y value is 15. You know your x value is 8 because that's the definition of tangent. Look at your picture. Which of these would be the negative? Well, it'd have to be the x value because you're going back 8 and up 15. So there's your x, there's your y. Now you need your r. So you would do x squared plus y squared equals r squared. However, if you're quick, this is one of your triplets. In your little list of Pythagorean triplets, there is an 8, 15, which means the radius, the hypotenuse, will always be 17. If you don't believe me, if you do the work, if you do negative 8 squared plus 15 squared equals r squared. Negative 8 squared is 64. 15 squared is 225 equals r squared. If you add them up, you get 289 equals r squared. You take the square root, and the square root of 289 is 17. But again, why do work if you can best memorize a rule? Fair? Now, you did all that. You haven't answered my question. Give me the value of the 6 trig functions. Get in a habit of writing them in the order I'm writing them in the notes so you always get them set up right. So who are we going to write first? Sine theta. Then we're going to write cosine theta. Then we're going to write tangent theta. Sine is y over r. So that is going to be 15 over 17. Cosine is x over r. Negative 8 over 17. Tangent is y over x. Well, you already told that one up there. Negative 15 over 8. Always write the original 3, sine, cosine, tangent. Now do the reciprocals. The reciprocal of sine is cosecant theta. So that's going to be 17 over 15. The reciprocal of cosine, secant theta. That's going to be negative 17 over 8. The reciprocal of tangent is cotangent. That's going to be negative 8 over 15. Are all those fractions acceptable? Sure, they're all in lowest terms. They can't be reduced. As long as you float all your negatives to the numerator, you're good. Now, I'm going to prove to you, you know you're right. Look very closely. What quadrant are we in? Quadrant 2. According to all students take calculus, which trig function should be positive? In quadrant 2, S stands for sine. Sine is positive, and its reciprocal is positive, which means the other 4 fractions are negative. Isn't that neat? Awesome. Okay, let's try one more. Okay, I'm going slow because I want to make sure you really get the definitions. So the next one, it says to find the 5 remaining trig functions given cosecant theta is negative 3 and cosine theta is greater than 0. If they give you 2 clues, they expect you to use both. Again, They're not giving you an ordered pair to plot to figure out what quadrant we're in. They're not giving you a line to draw. This time they're not telling you what quadrant explicitly. They're not just coming out and saying Quadrant II. So which piece of information here is going to help you decide on your quadrant? Well, right here, first of all. What does it mean if cosine is greater than 0? Well, greater than 0, what kind of numbers, people? Positive. If I look up here, which quadrant is cosine positive in? A means everyone's positive, so the triangle being Quadrant I, and C means cosine is positive. So right now we got it narrowed down. Our triangle could be either in Quadrant I or Quadrant IV. But they're not asking us to draw two different right triangles. They need one right triangle for us to define the trig functions. So now we have to use this other piece. What function is that? Cosecant. What do you know about that number? It's what, y'all? Negative. So by knowing this, we know that cosecant's got to be negative. So let's look. Would your cosecant fraction be negative in Quadrant I or Quadrant IV? Well, A means everybody's what? A means everyone's positive, so it can't be Quadrant I. That's out. Then it must be Quadrant IV. The problem you guys all have is you associate this word with the wrong trig function. C means cosine, and what goes with cosine is secant. So if cosine is positive here, cosine's positive here, secant's positive here, it means everybody else would be negative. So this would be Quadrant IV. So now we know we could draw our right triangle in Quadrant IV. So here we go, vertex point, initial ray. Here goes our terminal ray. Let's drop our perpendicular. All right, now we need numbers. Well, the only number we have is -3. That's not technically one number, it's technically two, because all 6 trig definitions are written as fractions. How do we write -3 as a fraction? We put it over 1. Now, what does it represent? Cosecant is is r over y. So here's your r value, here's your y value. Can your r value be negative? Absolutely not. What happened here is they took that negative and floated it up. It really belonged here. The radius is always positive, so our radius is 3. Our y value is really -1, which makes sense. We went down. Now, do we have a triple here? No, we do not. So we're going to have to do Pythagorean theorem. We don't know x. So we have x squared plus -1 squared equals 3 squared. Make sense? X squared plus 1 equals 9. X squared equals 8. We square root it. 8 is not a perfect square, so you have to reduce it. Again, here comes the problems. Do you remember how to reduce a root from algebra? What perfect square is in 8? 4. 8 is 4 times 2. What is the square root of 4? 2. A 2 comes out. Can you square root the number 2? No, it stays inside. So that x value is 2 square roots of 2. And it's positive because the x value in Quadrant IV is always positive. It's a lot of thinking. It's not a lot of work. It's a lot of thinking and knowing what everything means. So from these 2 clues, I had memorized a lot of facts that got me to this picture. I used my algebra skills to get the r value. Have you answered the question yet? Oh, heck no. You haven't found the 6 trig function values yet. You've just done all this work to get started. So let's do it now, guys. Let's write out the 6 trig functions. Let's keep them in a pattern. I'm telling you, it's all about repetition. So I want to know sine theta, cosine theta, tangent theta. Don't forget to put the theta. If you don't put the theta, I got to mark you wrong. If you just write sin, I got to mark you wrong. That's a sin. Label. You have x, this is y, this is r. Now know your definitions. Sine is y over r. Cosine is x over r. Tangent is y over x. Make sense? All right. Are all 3 of these acceptable? Heck no. Which fraction is not acceptable? The third one. You can't leave a square root in the denominator. So how do you rationalize 2 square roots of 2? You just have to multiply by another square root of 2, people. This 2 is a whole number. It could stay. Okay? So in the numerator, we get negative 1 times the square root of 2, which is negative square roots of 2. In the denominator, we have a whole number 2. We're going to leave it. What's square root of 2 times square root of 2? Well, that's square root of 4, which is 2. So this 2 times this 2 would make 4. You can't do anything more. That 2 is inside a root, so you cannot break it down and divide it with that whole number 4. Now we can do the reciprocals. Who's the reciprocal of sine? Cosecant theta. So if this is negative 1 over 3, this is going to become negative 3 over 1, which is just negative 3, which we already knew. We were told that. Who's the reciprocal of cosine? That is secant theta. So this is going to become 3 over 2 square roots of 2. Who's the reciprocal of tangent? Cotangent theta. Now the question is, when you do the reciprocal, would you use the simplified version of the fraction, or would you use the original fraction? Well, again, try not to make more work. If you use the simplified version and do the reciprocal of it, then you'll have the square root in the bottom and you'll have to rationalize. If you use the original, there'll be no rationalizing, because 2 square roots of 2 would go in the numerator over negative 1. Now, the question is, can I leave these? This one I can leave. This one I cannot. I got to rationalize. I got to multiply by square root of 2 over square root of 2. So I get 3 square roots of 2. And again, this 2 stays. Square root of 2 times square root of 2 is 2. So a 2 times the other 2 makes 4. This I cannot leave the negative. It floats to the top. And we do not leave a denominator of 1. I'm going to double check myself. What quadrant we're in? Quadrant 4. According to all students take calculus, in quadrant 4, the cosine value will be positive. That fraction's positive, which means its reciprocal is positive. All the other 4 fractions, if you look, are negative. So that will be another helpful hint. Even, guys, when we get to use the calculators, you're going to be relying on this fact, knowing who's positive or negative, so you know you typed it into the calculator correctly. All righty. I'll see you in the next video.